Morning, everybody. Morning. Because let's go talk about mathematics today because we study DevOps in academia too. So, well, this is a work about my master degree that I have in Rio de Janeiro, and we are going to talk about integral programming to optimize calls in Kubernetes. It was inspired in a work that I read that is deep reserve. It's a thing that involves AI, deep reinforcement learning, solving NP hard scalability for edge computing, and also connected vehicles like Uber and Didi, whatever, using a model that it's capacitated facility location problem, that it looks for the best locations to the new installations. So what we want to do using this model is that use that for Kubernetes. So what we want to do is that find the best pod to the best node to a pod using a formulation to reduce costs and thinking about things about node affinity and costs and errors and also performance, things like that. So we created a formulation of an integral linear programming focusing to optimize this relation between nodes and pods. And we created also two algorithms to compare and Kubernetes default working with kubescheduler and our formulation implemented on that. Because what we want is a model that allows us to identify an optimal level using a Groby that it's a library to find optimal solutions, reducing costs in a mathematical solution, and in the future, implement that in a real cloud. This is only mathematics. It's going to be some in the next slide. But what we want to do is implement my PhD that I'm doing right now in the Federal University of Rio de Janeiro in the cloud. I know that it's too much, but yeah. Alpha in this formulation means if a node is opened or not, and it impacts the cost of the final solution. And we have beta, that it means where do we put the sum of pods that are attached to these nodes, and about the size of the machine, memory, CPU, and whatever. And J is about pods, and I is about the nodes. And we have also a penalization with gamma, that it's about the penalization of if the pods have errors or not. If they have errors, I know that it's hard to count this, but we did that in a mathematical way. And if we have more errors, we need to increase the solution, the final cost of the solution, and we want to reduce that. We have some constraints that they simulate a real Kubernetes working, kind of like that. So we need at least one node, assign a pod to a node. All open nodes need at least one pod, focusing in, like I said, simulate this relation of kubescheduler working, but in a mathematical way. We have also in the 4 constraint the sum of capacity of all pods allocated in a node. It can be higher than the capacity of the node. And also the 5 and the 6, they are about if X and I, they are binaries or not, because we are talking about a formulation that it's integral programming. So we need to put in the variables of decision that they are alpha, beta, and gamma values like 1, 3, 100, and we tested like lots of solutions for pods and for nodes. We tested that in a GitHub, and we have that in the final QR code of these slides. And so it was implemented in Java because Groby works for Java or Python. And Groby, like I said, we can implement seeds to find final solutions. And our solution, it's in blue, and kubescheduler that we tried to implement and simulate, it's in red. And what we see is that using the same quantity of nodes, we have less cost in a mathematical way, but we take more time to attach the quantity of the pods to the nodes because, well, we need to search like one by one the best node to a pod. So that's why Angurobi takes a long time, but we want to reduce that and whatever, put that on Go. I published that in Belgium and not only in Brazil, but in a conference called International Congress of Ultramodern Telecommunications last year in Ghent. Ghent's a beautiful city. And what I want to do next in my PhD, like I said before, is implement that in Kube Scheduler with Go and a real cloud that it can be whatever we want, and in more ways like to understand and deep dive in memory, CPU, and whatever. That's me. I'm DevOps Days core engineer. I'm organizer. I'm also an SRE engineer at Starblock. And if you want to read my paper, that's my QR code and whatever you want to know about my working community. Thank you so much.